Okay, hello everybody, this is Ms. Piekarski, and this is the review for your Unit 4 test. Half of the test questions are going to be based on application problems like this one where you have a Ferris wheel, and this one they give you the formula, and you have to put it in a calculator and graph it. It is not going to give you what your window parameters are going to be. You need to figure that out. For example, on this one, make sure it just asks that you show 3 complete cycles or revolutions. So on this, you would probably want to find the period length. Use your b value to find the period length, times that by 3, and then so your x values would be from maybe 0 to whatever 3 period lengths are, and then your y values, just make sure you can see the whole cycle. It'll end up being a sinusoidal graph where you're going up and down because it's the sine function. And then let's see, what other types of questions might you have? The greatest height achieved by the Ferris wheel, so your maximum point, and then what time that occurs, and then your minimum point for the next one, the diameter of your Ferris wheel. So just from the maximum to the minimum, that length is going to be, will give you your diameter. And then according to the function, for what length of time would a person riding the Ferris wheel stay at or above 100 feet off the ground in one full rotation? So I'll show you an example. If you have your graph that goes like this, well, if 100 feet off the ground is here, you want to figure out what the x and the y value is here, what the x and y value is here, and your x is time. So if you were trying to figure out a problem like this, you would find this x value, find that x value, and subtract them from each other to see how much time the Ferris will be, or you will be above 100 feet on the Ferris wheel. Okay. To find your maximum minimum points on that, you can kind of do the same thing. You have the graph like this. Use your menu for your analyze graph function on the calculator. Find the maximum point. You'll have to do like lower bound and upper bound, move it to the left of the maximum point, move it to the right of the maximum point, and then it'll give you your x and y values there. So you can do the same thing for minimum points, lower bound, upper bound, find your minimum. Super easy. We've calculated minimum maximums lots of times. If you've forgotten how to do that and you need help, come in early to class and I can walk you through it real quick. It's not very difficult. All right, and then here's another application problem that you might get where you have a table and you have to figure out the minimum and maximum points. So with this one, your 10 looks like that would be your minimum. The 14.3 is your maximum. You've got to figure out where the midway point between 14.3 and 10 is. That'll give you your sinusoidal line. And then the distance from your minimum to your mid sinusoid, your d value, that'll be your a value. And then you can graph it from there. And then, hold on, see this, so the cycle would probably be just 12 months. No, hold on, January to January, yeah, it's just 12 months. So your period length would be 12 and you would have to calculate your b value. So most of you should be able to answer problems like this. If you look at it in the video, if you're struggling, if you don't understand something, come in for tutoring and ask questions about it. All right, and so those are the examples of the application problems that you'll have, and then you have 10 multiple choice questions. Some of the things you'll need to know for the multiple choice questions are you might have to find where, for sine or cosine function, you might need to find the x values for when y equals 1. Well, if y equals 1, you have this point and this point, and the x value there is pi over 2. But we know that with the sine function, it's going to keep on going this direction forever, and it's going to keep on going this direction forever. So to find all of the times that your graph will get to positive 1, then you're actually going to have to create a formula. okay, because our first positive instance is at pi over 2, and then the distance apart is 2 pi, and then, so that's where this comes from, and then the k is just how frequently that happens. So k is just an integer. Remember, integers are whole numbers. That just means whole numbers. Okay, so it can be a positive or negative whole number, doesn't matter, just as long as it's increments of 2 pi. Okay, we kind of went over this several days ago. For cosine, if you have a type of the test version where you have the cosine function, you get to 1 when x is 0 and when x is 2 pi. Because 2 pi is your first positive one, then it will just be 2 pi times k, where k is an integer again. Integers are just whole numbers. So if k was 0, 0 times 2 pi would give you 0. If k was negative 1, you get negative 2 pi. So you'll get all of your solutions when y is equal to positive 1. Now, you might have one of the test versions where it asks you about negative 1. For sine, you get to negative 1 at negative pi over 2 and 3 pi over 2. And again, with this one, it's going to keep on going because your graphs keep on going forever and a day to infinity. And so you'll have a formula, and these are 2 pi units apart. These are 2 pi units apart. Everything, because of your cycle, is 2 pi. It's just 2 pi units apart. And again, your first positive one is 3 pi over 2. That's your first positive answer. And then increments of 2 pi times k, and k just has to be a whole number. Okay, down here for negative 1, if you have the cosine function, your minimum points are at pi, and then they're 2 pi increments apart. Okay, so just be aware that you can't just say x is only pi or only 2 pi, because the function keeps on going. Okay, make sure you understand what the formulas mean and how to set them up. All right, here's the next one. Find the amplitude and period for these functions. Just remember your amplitude, that is your a value. It gives you your amplitude. So for this function, your amplitude is 4. For this function, your amplitude is actually 2. Okay. For the amplitude, we just want the absolute value. Okay. The negative just means that you're reflecting. The amplitude is the distance from your minimum point to your maximum. And because it's a distance value, it's absolute value. It would be positive 2, not negative 2 here. Okay, and then for your period, just remember to find your period. It's 2 pi divided by your b value for sine. So for here, your b value is 1/3. Anytime you have a fraction, you have to multiply by the reciprocal. So you get 2 pi times 3 over 1, since the reciprocal of 1/3 is 3 over 1. And then you can't cancel out a pi, so you just multiply the 2 times 3 and you get 6 pi. Right here, your b value is 2. Those cancel out and you're left with a period of pi. Okay. How does the a, b, c, and d transform the sine function? You might want to look at your notes. You need to know this. Your a is a vertical stretch, okay, or shrink. If a is greater than, notice these are absolute value signs. If a is bigger than 1, then you're stretching. If it's a fraction, if it's a fraction, you're shrinking. And then if it's a negative, you're just reflecting over this sinusoid. Okay. Your d value, moves you up or down. That's your vertical translation. Your b value is your vertical. So if b is a fraction, if b is a whole number greater than 1, then you're squishing together, you're compressing or shrinking. If it is a fraction, you're stretching. We really don't do any type of reflections with your b value. And then just make sure you remember how to find your period here. the period is 2 pi over b, and if you have your b value, or excuse me, that's for when you have your b value and you're looking for your period. If you have the period and you need to find b, it's 2 pi divided by your period, okay? Very similar, you're just switching the p's and the b's, okay? That just switches places, okay? So let's see what else. So your horizontal shrink and stretch, your phase shift, if you shift left or right, if your formula says x minus a c value, then you're moving to the right. If it says x plus c, you're moving to the left because that means that your c is negative, okay? Let me move this around so we can see it all. Okay. You should all have this information. Make sure you know it. You might want to write it down on the index card. All right, which trig functions are even and which are odd? This should be in your notes. Your sine function is odd. Cosine function is even. Tangent's odd. Cotangent is odd. Your secant is even and your cosecant is odd. If you filled out your purple notes, you should have all this information. The only two trig functions that are even are cosine and secant, and all the rest are odd. Okay. This is another application problem. It'll be a multiple choice version. All right, it's in the multiple choice section of the test. A buoy bobbing up and down in the water moves from its highest point to its lowest point and back to its highest point in 50 seconds. So that's your period here. This is your period length is 50. The distance between the highest and lowest point is 11 feet. So that would be kind of like your diameter. So half of that is going to be your amplitude. So for this, your A value, you do 11 divided by 2, you get 5.5. For the period length is 50, so that means to find your B value, 2 pi divided by 50, and you can reduce that to pi over 25. And then to create the formula for this, it would be 5.5 times cosine times pi over 25 pi over 25 times x. Why are we using cosine instead of sine? Well, let's look at this. So it moves from the highest point to the lowest point and back to the highest point again. So we're starting at the highest point, okay? Because we're starting at the highest point, then we're going to use cosine, okay? That's the only reason why we chose cosine. All right, let's move on. I think that was it. Yep, we don't have to worry about our D value or C, just A and B, okay? Another type of formula where you'll have to give a formula for where the asymptotes are. If you have the version where you have cosecant, you need a formula for the asymptotes. So your asymptotes are at pi and 2 pi and 3 pi and 4 pi and 5 pi. So it's just pi times some integer. And again, integers are whole numbers. And that's your formula for if you have the version with cosecant. If you have the version with secant, your asymptotes are at pi over 2, and then 3 pi over 2, and 5 pi over 2. You'll notice that your n value here would always has to be an odd number, okay? Because if it was an even number, if you said, let's say you said 4 pi over 2, well, that reduces to 2 pi, right? Okay, 4 divided by 2 reduces to 2 pi. Well, if you look at 2 pi, you do not have an asymptote there. So if you have secant, then your n always has to be an odd integer, okay? It just means an odd whole number. Because the even whole numbers will you won't have an asymptote there, okay? One thing that you might find interesting is that cotangent and cosecant have the same formulas for your asymptotes, and tangent and secant have the same formulas for your asymptotes. Okay, so if you have secant or tangent, then your formulas are going to be pi times n divided by 2, and n has to be an odd integer. Make sure you remember it has to be an odd number. And then here for cotangent and cosecant, it's in pi and in just increments of pi. So 1 pi, 2 pi, 3 pi, 4 pi, and so on. Okay. What's the domain and range for a sine function? The domains are always very easy, from negative infinity to positive infinity. They never stop. Your range could be a little bit difficult because you have to consider your d value. Okay, where's the sinusoidal line going to be? In this case, you move the sinusoidal line up to when y is 3.5, and then your a value, your amplitude, is 2.5, so you're going to go up a little bit more to 2.5 units up. Okay. And then you're also going 2.5 units down. So your range will be from what, 1 to 6. Okay. 3.5 plus 2.5 is 6. 3.5 minus 2.5 is 1. So in this case, your range would be from 1 to 6. And then down here, same kind of thing. You're moving your sinusoidal line to 2, and then you're going up 6 and down 6. So 2 plus 6 would be 8. 2 minus 6 would be -4. So your range here would be from -4 to 8. Okay. When you get this problem, make sure you take into consideration your d value. And then what is the vertical shift for this function? In this case, that you're looking at your d value, vertical shift, are you moving it up or down? In this case, because it's a plus sign, where it's going 3.5 units up. Over here, it's 2 units up. Okay, super easy, right? And then what are the periods for these functions? Remember, to find your function, or to find the period, is for the sine function, it's 2 pi divided by your b value. I just realized I have an error here. Let's look at this one first. 2 pi divided by b. So it's 2 pi divided by, my b value is 2 pi over 3. I have a fraction and a fraction. I'm multiplying by the reciprocal. The 2 pi's cancel out, and I'm just left with 3. So for this example, my function is, or my period is 3. Over here, have you spotted the typo? I need to get rid of this 2 here, because for your period, for tangent, the period is equal to pi divided by b, not 2 pi divided by b. Okay, so I got to erase this 2 here, and then that's going to change this period length. Okay, and then, so for this one, the formula is, the period is going to be pi divided by b, or 1/2. I have a fraction and fraction. Well, the reciprocal of 1/2 is just 2. So your final answer will be just 2 pi. Okay. And that is the end of my review. I hope you use this review. Please fill out your index card. You can use your index card and your trig table on the test on Monday. Okay. Good luck. Bye.